we now need to address something that is common to all physical measurements, and that is namely error. Specifically, error in these at-a-point estimates of precipitation. Let's consider our standard rain gauge here. This is a standard tipping bucket gauge. This is the funnel that goes on top. This is a little data logger. And inside here is the little tipping bucket that goes back and forth and records rain gauge, or that records rain as it comes in. So what are the ways that this thing can be in error? Well, the first one is that there may be obstructions that block the rain from getting in here. And I'm going to categorize all of these error things as common issues because they're things that everyone needs to deal with. And the error that they tend to result in is systematic undercatch. And by undercatch, I mean that the rain gauge is underestimating the true amount of rain. So, obstructions. This is the first common one. Consider, for example, a forest, and then you have a clearing where you've decided to site your rain gauge, and it's usually up on a little pole off the ground. So this is the rain gauge here in this clearing. The issue here is that if it's windy, for example, let's say the wind is coming in this way and it's causing the rain to blow this way, this obstruction, or the tree, is going to block some of the rain from reaching the gauge, and therefore it's going to result in an underestimation of the actual amount of rain that's falling. In general, we would like our obstructions to be at least 4 times the height of the nearest, our gauge to be 4 times away horizontally the height of the nearest obstruction. So we would like to site the gauge at least 4x away the height of the obstruction in order to avoid this issue. Another very common issue is the phenomenon of rain splash. And the idea here is that even though this funnel has this little lip on it, on the top of it, it's still possible that raindrops coming in at very high speed will bounce off of this sloped funnel surface and get ejected from the rain gauge. And obviously, this rain should have been counted, but because it's being bounced out of the gauge, it's not going to be counted, so that's a bad thing. One of the other common issues is a phenomenon known as wind-induced undercatch. And the idea here is that if you have a rain gauge that's up on a pole and it's windy, the wind, as it's moving about the gauge, can result in eddies, little turbulent motions of the air that will advect raindrops that are falling and that should have landed in the gauge out of the gauge, and so they won't be counted. So this is, these are known as eddies that redirect drops. And this is particularly important for small drops and snowflakes. And I think you can understand that. If if you think about it. The less mass, the less density that these falling bits of precipitation have, the more easily it's going to be for a little gust of wind to grab them and make sure that they don't fall in there. It's possible that this can result in a 10% undercatch in many areas if it's not dealt with. One of the ways that we deal with wind-induced undercatch, a solution, a partial solution, it's not perfect, is by making a little shield around the gauge. So if this is your gauge that's up on a pole, you put a ring whose height is about the same as the top of the gauge around it, and then there's hanging off of it these little baffles, and they can kind of blow in the wind. And the idea is that the wind's blowing through, they're on all sides, and it blocks the wind eddies, and so it allows the rain that's falling in on the top to fall smoothly here into the gauge. Alternatively, you can rely on an empirical calibration to correct for wind-induced undercatch. And these calibrations usually work where in places where you have next to the rain gauge a wind gauge that's measuring the amount of wind and its speed, and if it's raining during a time when it's very windy, you add some of that rain back in with this empirical correction. There's one other, unfortunately, very common reason that we might underestimate or undercatch the amount of precipitation that's happening, and that's because these things are installed in remote areas very commonly, and quite simply, you might have power or instrument failure. So your solar panel could get knocked down, your battery could die, a bear might come along and knock your gauge over, a bunch of ants or mice might decide that it's a good time to chew through your wires. All of these things happen, and they result in you missing some amount of rain and not measuring it. So these are all the common ways that we can get error in at-a-point precipitation estimates, and usually they result in an underestimation of the actual amount of precipitation.